Hello, everyone. Good morning, good afternoon, good evening, wherever you're joining us from. Thanks for attending today's Stantec Water webinar series presentation on building strong public partnerships for your next water infrastructure project. My name is Ryan Rodall, and I'm a marketing director with Stantec. I'll be your moderator today. Before I turn it over to Steve, just a few items to note. First, you'll be muted during the presentation, but please feel free to comment or ask questions at any time using the GoToWebinar questions panel. We will get to those at the end of the presentation. There'll be most likely around 15 minutes or so left for Q&A after Steve's presentation. Also, if there's time, depends on the number of questions, I will open up your mic with maybe 5 minutes left to let you comment or follow up on a question if you'd like. All depends on how many questions we get for that. I'll also follow up with a certificate of attendance within a week or two that you can use to submit for PDHs. Obviously, it's up to your local certifying agency, but I will get those out. And we post all recordings of all of our presentations, webinars back to the Stantec Water webinar series page on stantec.com, and we'll put that in the chat a little bit later so you have a link to previous webinars, our schedule for upcoming webinars, and et cetera, et cetera. So with that, I'm going to turn it over to Steve Mathies. He's our Coastal Restoration and Resilience leader for the Water Group at Stantec, and he will lead the presentation.
Good morning, folks, or good afternoon, depending on where you are. Again, my name is Steve Mathies. I am in the Stantec office in New Orleans. And for this presentation, what's more importantly is that I grew up in the New Orleans area. I lived in the city before the storm and during the storm and after Katrina, and I continue to live there today. I truly appreciate the opportunity to talk to you all today because this is something that I think touches all of us. The story, the story I'm going to tell you is really about the city of New Orleans, what we were like before, during, and after Katrina. And this story is really personal to me because, like I said, I'm from New Orleans and my family's lived here for generations. And I just offer this story as it might help you when you're thinking about how to protect your community from a similar storm event. And know that, at least from my perspective, you probably have a similar storm event in your foreseeable future. And just so we all kind of know how the presentation is going to go today, recognizing that a lot of you all are not familiar with the physical landscape of New Orleans or the surrounding area, I'll talk a little bit about how Louisiana's coast was formed. That way, when we get to some of the solutions and some of the actions that we're taking, it'll make a little more sense to you. And then we'll talk about broad solutions and specific projects within those. We've kind of grouped those into three different buckets. We'll kind of talk about how the federal government responded immediately after Katrina, how their state is responding now, and how the local government is responding now. So with that, we'll just get started real quickly here. Recognize that the Mississippi River, at least, I believe that's probably the most important physical attribute that accounts for the success of the United States, the economic success of the United States, would be the Mississippi River. And I say that because, nowhere on earth is there a river system with more miles of naturally navigable stream than the Mississippi River watershed, and nowhere in the world is that overlaid with this vast area of farmable land. And that is actually what drove the purchase of the Louisiana Purchase from France in 1803, because it was recognized that this was so important to the economic development of the United States. Now, for this talk, what's really important about the Mississippi River is that it drains 31 states and 2 Canadian provinces, and all of that water and eroded sediments that are in it flow to the Gulf of Mexico through Louisiana and past New Orleans. And I say that because over the past 7,000 years, coastal Louisiana, and if you look here, this is coastal Louisiana. The city of New Orleans is right here. Lake Pontchartrain is right here. The Mississippi River runs right here, okay? So recognize that over the past 7,000 years, the river has meandered a number of times, and those deltas that were formed really is today with this coastal Louisiana. So we've got a series of overlapping deltas, and under natural circumstances, as the deltas compress and subside, there's no big deal because the river continues to overflow and it lays down more sediments, on top of those deteriorating marshes, and it kind of rebuilds those deltas, and that's usually not a problem. But for us here, after we had the Great Flood in 1927 in this country, the Mississippi River was leveed to prevent future floods and to funnel all of that water and sediment to the Gulf of Mexico. And when I say that the Great Flood, it wasn't that coastal Louisiana was flooded. It was the whole Midwest and the whole upper Mississippi River Delta. The agricultural lands were flooded. So the idea was, how do we capture all that flood water and get it to the Gulf as quickly as possible? So our coastal landscape continues to compact and sink, and with no new sediment deposits on the surface, we have a lot of our coastal landscape has actually converted to open water. And again, remember this map and think about, here's the mouth of the river down here. This is the Mississippi River, and this is the city of New Orleans. So next, think about this image, and I want you to remember this image for the rest of the talk, because when I said the Mississippi River, we no longer have overflows. We kind of ended that after the flood of 1927. So, what's really happened is that the past 90 years, we've had this continued compaction of the marsh sediments, and we've had no new addition of sediments on top of that. So what you see here is this devastating land loss that we've experienced. And since the last 90 years, we've lost about, 1 million acres of contiguous wetlands have been converted to open water. And so this ecosystem collapse, I believe, is probably unmatched anywhere in the world. And it threatens our communities and the way we live in coastal Louisiana, because you think about how important all that land is if you have a hurricane surge, okay? And for the city of New Orleans, we historically had 30 miles of contiguous wetlands between the city of New Orleans and the open Gulf. So just remember this image as we kind of go through our talk here. Okay, so along comes Hurricane Katrina. But let me back up a little bit and say, I mentioned before that I'm a native of coastal Louisiana, and being a native and being an old guy, I lived through Hurricane Betsy in September of 1965. I was 11 years old at the time. And, I had always heard in my life that I had already lived through the storm of a lifetime. Okay. So I got to tell you, my mindset after that was that I've already lived through the greatest storm that I'm going to see in my lifetime. I offer that because Hurricane Katrina changed everything. Where we thought we only had one of these storms in a lifetime, then along comes Hurricane Katrina, nearly 40 years to the day from Hurricane Betsy. Now, with Hurricane Katrina, we had nearly 2,000 people killed, and we had nearly $100 billion worth of damages. But you look back on Hurricane Betsy, Hurricane Betsy was a similar sized storm with a similar path, and we didn't have nearly the destruction. We didn't have nearly as many deaths or nearly as great a losses as we had in Hurricane Katrina. And why was that? And I say, remember back to that land loss map, because during Betsy, we had those 30 miles of contiguous wetlands between the city and the Gulf, okay? So look at this image. This is the city of New Orleans about a week after Hurricane Katrina hit. Winds for Hurricane Katrina peaked at 175 miles an hour, and we had a 28-foot surge. But look at this, because when I look at this, this is what my home looked like after Hurricane Katrina. So for everybody on the, the audience here, think about what you would do if that was your home, okay? So just so we kind of, before we talk about solutions here, kind of understand what the city of New Orleans looks like in a cross section. So the little map at the top there goes from the Mississippi River, New Orleans. You see the little A there and the B at Lake Pontchartrain. It's a cross section between the river and the lake, and it's really looking at elevations. Now, if you know anything about deltas, when a river overflows and it's building a delta, the heaviest grain sediments are deposited closest to the river, okay, because they're the heaviest, which means you end up having the highest elevation land closest to the river, okay, which is what we have in New Orleans. If you look at these areas in this part of the city right here, if that part of the city would extend along here and along the rivers, close to the river, okay? So it's a higher elevation in this area. That is actually the footprint of the old city, okay? As you get further away, we have areas that are as low as nearly a -10 before it reaches back to about a foot at the lake. So in reality, we do live in a bowl in New Orleans, and every drop of rain that falls, we've got to figure out a way to manage that drop of water. Okay. Again, these are some facts about Katrina. Recognize that this was truly, a storm we've never seen before. The path of the storm is such that, and you see the storm here, the wind kind of blows from, it's a counterclockwise fashion. So as it's coming on shore, it's blowing water from the Gulf into Lake Pontchartrain. And then when the eye passes, the direction of the winds it's no longer from the south or the east or wherever. It's from the north, and it takes all that water and it pushes it back on the city of New Orleans. And that's what caused the overtopping of the existing outfall canals in New Orleans, and that resulted in about 80% of the city being flooded. Okay? The 20% of the city that did not flood, that was the old city, and that was the area settled closest to the river and the highest elevations. And so you look at this, and this is my slide that says, this could never happen, sort of thing, right? We have Hurricane Katrina that comes up through the city of New Orleans and coastal Mississippi, and it takes out the entire east side of the state of Louisiana. But then, lo and behold, 3 weeks later, we have a very similar storm, comes up, goes through Lake Charles, Louisiana, and Galveston up through Houston, and takes out the western side of the state of Louisiana. But that obviously, that had never happened before, and it could never happen again, right? Well, almost 3 years to the day, we had Hurricane Gustav come ashore and take out the eastern side of the state. And 2 weeks later, we had Hurricane Ike take out the western side of the state, Galveston, and Houston. Okay, so I just offer that to say, if you think it can't happen because it's never happened before, believe me, it can, and probably it will. Think about this. This was just our hurricane season last year. We had 8 named storms that coastal Louisiana at one point was in that cone, of uncertainty. Now, out of those, probably our most devastating storm was Laura. It did cause a good bit of damage in coastal Louisiana. So now we'll jump and we'll talk a little bit about how the federal government responded post-Hurricane Katrina. And, we're very fortunate in that because of the emergency response, the Corps of Engineers was given a pot of money, about $15 billion, and they moved forward very quickly with upgrading our existing, at that time, what we call the hurricane protection system. But after this, we realized that you really can't protect a city from any size storm. So they changed the name and now call these the storm damage risk reduction systems. But the Corps was very fortunate. We were very fortunate. They had money. They came in. What we had in the storm, we had the hurricane surge really overtopped the levee, and we had 50 different levee breaches. We had 34 of the city's 71 pump stations were damaged. We had 169 miles of levees and flood walls that were compromised. And then also, during the storm, we also had this 14 inches of rainfall within a 24-hour period. So the Corps' system was what we've got in New Orleans now is really a greatly improved system that strengthened the levees and the flood walls and gated structures and pump stations. And it also, and we also had several really technically, advanced engineering solutions that were implemented in this project. The first one up here to the north, up here to the east, over here is the IHNC lake-borne surge barrier, and that was created to stop the surge that was coming from the east. It provided great protection for the eastern portions of Orleans Parish and St. Bernard Parish. It was basically nearly a 2-mile barrier. It's the largest of its type in the world. It has 3 gated structures, and the top elevation of that barrier wall is a plus 26 feet. On the west bank of the river, right down here, this West Closure Complex provided a great deal of protection for the West Bank, for Harvey and Algiers areas. It is another the first project, the surge barrier, is about $1 billion project. This is about $1 billion project, and it really has our nation's largest sector gate. It is the world's largest drainage pump station. It has flood walls, sluice gates, and earthen levees as well. Really, what I want to talk about is what happened in this area right here. And this is the project I was talking about. It is it's a permanent canal closures and pumps project, and I'll show you this map just to kind of see. The pump stations are up here on the levee, but our major internal drainage stations, pumping stations, are down in this area. And the reason that is because historically, when these pump stations were built at the turn of the century, and I don't mean 2000, I mean 1900, that was the edge of the city. And so you had the pump stations, you had the internal drainage system, collects all the water, and then it would just pump it into the swamps that historically existed between the city, which would have been, down in here, and Lake Pontchartrain. Well, over the past 120 years, we've grown out past, we developed out past those original pump stations all the way to the lake. And the way we responded was not by moving the pump stations to the lake, which was recommended actually by the Corps probably 40 years ago, but we built these long outfall canals. And these long outfall canals really what caused the problem, because you have pump stations inland, and then you have the large pump stations, and then they're open to Lake Pontchartrain. Hurricane surge pushes water down and overtop the flood walls, and that's what fills the city. That's what fills the city with water. So these pump stations, they have a typical layout where we've got the bypass gates over here, and those remain open all the time, because you have to realize that under normal conditions, non-storm events, these stations are not functional. Okay, so we operate the way we always did. We have these long outfall canals, the internal pump stations, which are vintage 1900 pump stations, pump water into those canals, and by gravity it flows to the lake. During storm events, you have to close those bypass gates and operate the pump stations. And because you expect that you're going to lose power during these storm events, you have to have your own generator building to provide that that alternate source of power. So we'll look real quickly, and we will look at all three of these pump stations. I'm going to show it to you real quickly, but realize that for all three of these pump stations, they have similar equipment. They have similar pumps, so that when it comes time for maintenance of these pumps, it's not like each pump station has unique parts that that have to be worked on or whatever. So the pump station to the east, the farthest one to the east is London Avenue. It has a total capacity of about 9,000 cubic feet per second, which is a pretty good sized pump station. The one in the middle is Orleans, and Orleans is the smallest. It has a capacity of about 2,700 cubic feet per second. It has 4 of the large generators and 3 of the large pumps. And then the really large pump station is the one on the western side, is the 17th Street Canal. And the total pumping capacity of that plant is 2,600 cubic feet per second. It has 15 of these large generators, and it has 6 of these very large pumps. So with that, I'm going to take you on a quick tour of what the inside of these pump stations look like. And this is the inside of the large pump station. And you can see here the vertical pumps. You can see the large gear motors. You see the large discharge tubes over here. And then also notice that here, this is a very unique feature. This is a crane system that allows you to access any point in the generator building. And this is again for ease of working on equipment. You can pick things up and move them, so it makes just the overall maintenance much easier. This is the size of the vertical pumps. They're very large pumps. Look at the size of the impeller here. This guy is John Take, and John is probably about 6'1", so that just kind of gives you a kind of an inkling on how large this equipment really is. And this is the generator building. Obviously, this is a very nice payday for Caterpillar. These are very large generators. They're 4,100, 600 volt generators, and the whole station we have to be capable of providing power independent for 5 full days. So this is we have large diesel storage units outside as well. So this whole project took only about 4 years from beginning to end. That is from the time you started to design to construction being complete on all 3 of these pump stations for a total cost of about $731 million. So the federal government's in there. They're building all the hard structures that surround New Orleans. So what is the state doing to help with this issue? Well, for the past 40 years, the state of Louisiana has known that we've had a land loss problem really on a global scale, and we had begun to take action. Okay, so we were taking action, but they were kind of small projects. And after Katrina, we really got serious about looking at the state and coming up with a comprehensive plan for how to preserve and protect the landscape of coastal Louisiana. And this plan included, direct restoration of wetlands, reestablishing hydrologic function, providing risk reduction measures for our most threatened communities, and that being levees and, in some cases non-structural, and then also reconnecting the Mississippi River to the deteriorating wetlands so that we could rebuild that storm buffer that historically existed. So if you look at the master plan, you probably see project types that you would be familiar with, that you might even use in your, in where you're from. Things like, if you're talking about structural protection, that's levees and flood walls and pump stations. Non-structural would be things like the raising houses or flood proofing. And then we restore the landscape of Louisiana. We restore ridges. We do a lot of shoreline protection. We do lots of work restoring our barrier islands. We have enormous marsh creation projects. And we have a couple of these very large sediment diversion projects. And one I'm going to talk about is Mid-Breton sediment diversion. And it's just called Mid-Breton because it's halfway, in the Breton Sound Basin, to the east. So look at that. So if you look at the specific location here, the project is going to be located right here, and it's located here because of 2 things. One, you've got ample sediment in the river here. This is on an accreting point bar, so you would be assured of having a continuous, sustainable source of sediment to feed into the diversion. In here, it has the shortest distance to cross the federal levee and the local flood protection levee to reach the deteriorating wetlands. And also, we've got, if you look here, you can see the city of New Orleans in the background, okay? So the whole idea is to rebuild this marsh area to provide protection to the city of New Orleans. This is a graphic of what the structure will look like. And, when I say that the structure is, it's going to be 75,000 CFS and will be operated when the river flows about 1 million cubic feet per second. That really is, to give you some idea what that is, 1 million cubic feet per second, that's the beginning of flood stage on the Mississippi River. The average discharge for the Mississippi River is about 600,000 CFS. But if you look at the 10 largest rivers in the United States, and the Missouri River is number 10, and it's at about 86,000 CFS. So this structure will be the same structure as St. Mary's River in southeast Georgia, which is the 11th largest river in the United States. So again, think about this. This is a very, very large structure. The main components we will have here will be the river intake, and then you have the gated structure, you have the conveyance channel, and then you would have the outfall channel associated. The gates, these would currently being designed. The gate structure would consist of 5 vertical lift gates. Each would be 48 feet wide with a base elevation of about -25. And then this is the receiving area, that we talked about. This is really important because this this project is critical for near-term restoration, and it's expected to reestablish the natural deltaic process, to reestablish critical habitat, and really to improve our coastal risk reduction. And the project is estimated to create or to restore 50,000 acres over a 5-year period. Okay, and then lastly, we'll talk about how the city of New Orleans responded to Hurricane Katrina. And I think this is one of the most really exciting stories for me to tell as a resident of Louisiana. Okay, recognize that before the storm, we had a lot of challenges, and those challenges that might be similar to your communities or where you're from. So if you are, you probably can relate to this. I mean, we have the physical stressors. We have really high intensity storms. We have climate change. We have sea level rise. We have extreme heat in the city, and we have over 55 inches of rainfall a year. And then we've got this, because of our soil types, these heavy clays. We have this strength swell soil, so we have a lot of subsidence and aging infrastructure, that causes damage to our aging infrastructure. And then too, we had the social stressors. And New Orleans is a place where we have high levels of poverty, unemployment, violence. We're always at health risk. I mean, everything we do in New Orleans, we drink too much, we smoke too much, we eat everything we have, we deep fry, we don't get a lot of exercise. So, we got all of these things that we have to accommodate, and we also live in this bowl, remember? So what I'm going to say is that the lowest elevation portions of the city are usually the least expensive land. So what happens is some of our low and mid-income neighborhoods are low, or just happen to be located in these lower elevation parts of the city. So that whenever you have this flooding event, and you have some cases that you have as much as 15 feet of flooding, it's something that we just it's hard to focus on that. And so we kind of focused on, the city has focused on resiliency and some of these challenges with portions of the city and partners of the city, like the Gentilly Resilience District, to begin sort of addressing these challenges. So what it took for us here is that we needed to think about how we dealt with water in a really different way. Before Katrina, and again, I will say, as someone who lived in the city before Katrina, we looked at water and said, how do we pump it out as quickly as possible? Now, after Katrina, we had a large contingent from the Netherlands that came over here to kind of help us address our problems. And, as most of you know, the Dutch kind of view water as sort of this living with water concept. And so that shift in the way that we think about water was something that really, we as citizens of New Orleans came to a realization and appreciation of pretty quickly. And I say that just because before the storm, we wanted to pump water out as quickly as possible. And then after the storm, we realized that we can't accomplish that. So we have to think about water in a different way, and how do we manage water? And the Blue-Green projects were really the start of that. Okay, how do we do that? So the existing conditions, like I said before, you look at New Orleans, you look at the lower elevation portions of the city, we have all kinds of issues. We have everything from the infrastructure. We have entire neighborhoods that are serviced by one pump station that has to rely on one pump station to drain a neighborhood. We have all these problems with subsidence, and how you operate the pump stations. If you pump the water too low, then you have so much compaction, it causes all problems with your other infrastructure, whether it be wastewater or water infrastructure. And then our communities, to be perfectly honest, with this increased frequency of storms and intensity of storms, people got really, and they still are really, really tired of this repetitive flooding. So, part of our project, the very beginning of our project, what had to do with a lot of engaging people about this new approach, this living with water approach, and this required a lot of focused, community engagement, so that people really understood this, the benefits of not just flood mitigation, but all the amenities that could come along with this to improve your community and improve your quality of life. And to find out what people really wanted, we didn't just schedule like project meetings and have people come, but we actually reached out and went to neighborhood events and festivals and meetings, and even in some cases went to people's homes to sit down and talk about what could happen. And this more engaging approach is something that is really required by any HUD funding which paid for this project. And we went out to the public and really tried to finalize our plans by talking with people one-on-one. So most of the people in Akron today, they do recognize that we can't just pump all the water out. And so when they came to our meetings and they understood, what was possible, they came to the meetings with very specific ideas about how to make their neighborhoods more resilient and more beautiful and more livable. And I got to tell you, that's something that you really, as a citizen, your kind of heart's just warmed by that people can kind of really come up with not just how do you get the water out of my neighborhood, but now how do you make my neighborhood a better place? And what we heard was some of the things that you would expect that we would hear. Okay, get the water out. And also I'll say what we heard too. And I guess this should be a lesson for everyone. People were a lot more vocal after the disaster. I think it would have been harder to have these meetings before the disaster, again, because most people thought, like I did, like I had already lived through the storm in my lifetime. So it's not something I have to worry about. After the disaster, people were much more open. And these were the people that came back to these communities and rebuilt their homes. And they wanted to really focus on how do I make my neighborhood and my life better? Okay, remember, a lot of these, Gentilly was an area that had 10 to 15 feet of water. We were very concerned about the social and environmental equity kind of issues. We had low-income neighborhoods that were now saying, how do I improve my quality of life and what that looks like? And so, some of the things we heard, didn't surprise us. But then I got to tell you, I think some of the things we did hear did sort of surprise, us old guys. And, people recognize that, for instance, that bike paths were good for their neighborhoods and good for their kids. Before Katrina, I don't think I ever heard anybody talking about going outside and riding a bike in uptown New Orleans. People wanted more green space. They wanted more parks. They wanted more landscaping. They wanted ways to slow down the traffic in their neighborhoods to make it safer for their children. Heck, for the first time, we started hearing that people wanted dog parks, which is something that we had never heard before. Which led to when we started our design work, it was, what were the project goals? And as you might expect, the water goals, that was something that was, kind of top of the list. How do we eliminate this nuisance flooding and reduce the repetitive damage to homes? And in our case, because you have people park their cars on the street and your house is elevated 2 or 3 feet up on blocks, right? The person in the flood usually is your car. So we had, and that's a real problem if your car continues to be flooded. So it was those kinds of things, along with, infiltration of water and, what do we do about this? It's really, really hot in New Orleans. And what do we do about providing, more shade space? And then really, the bottom line for all of this was, if HUD funding allowed you to look at other goals to improve public health, like providing access to parks and recreation, or the economic goals of how do you make this community more to thrive easier, and it can be workforce development, or it can be higher property values, or how do you redevelop areas with confidence. All of that was incorporated into the overall plan, or has been incorporated into the overall plan. What you see, this is the plan as we have it today, okay? And, this is one of those areas that it's about 8 miles. and it includes everything that we see here. It includes stormwater storage, which is key. It has, just a lot of landscape improvements, and it has this implementing this complete streets concept, which has a lot of benefits to neighborhoods as far as pedestrian crossings and walkways and bike lanes and all that kind of stuff. So let's talk a little bit about this main concept, and that is water storage. If you look at this, if you come to New Orleans and you're talking to locals, we refer to the area, the broad grassy area that's in the middle of an avenue or boulevard, but we refer to that as the neutral ground, because historically in New Orleans, when our ethnic neighborhoods in uptown New Orleans were going to come together and trade, like folks from the Italian neighborhood would never just go into the German neighborhood. They had to have this neutral area that you could come to and you can visit and trade, and that was called neutral ground. And in our case, the neutral ground was always built up higher than the street level, so when it rained, the rain, hit the nice grassy area, ran off into the street, and you had to worry about that water going into the drainage system. Well, one thing the Dutch thought is they came and said, well, you get this all backwards. You need to turn that upside down. And you need to take those neutral grounds and make them depressed areas, lower elevation areas, so that during storm events, they will serve as a water storage area that water can be collected and then slowly released to your drainage system, which is what we've done here. You can kind of see what it looks like, a rain event and a dry event. And again, this is this kind of engineered design. What does it look like? You have permanent water that's held in the canal. You have capacity for the floodwaters, and then you're able to couple this whole design. This is a way of optimizing the operation of your pump station, of course, but how do you make it better for the whole neighborhood? And you can incorporate these amenities like walking paths and bike paths and landscaping and lighting and that type of thing. And then finally, this complete streets concept was something that was really embraced by the neighborhood. People wanted to make crossing the streets safer for pedestrians, do these bump outs, which cause slower traffic. They like the connectivity between the neighborhoods, and bike riders. So listening to what their needs were, it really enhanced these streetscapes, and the adding of rain gardens to store water and the bump outs, and enhanced signage and markings and that type of thing. So this is going to be a very highly visible improvement to the community. We're almost at the end here. One last major thing with this project was that there was a major intersection, and the city owned the 4 lots, the large lots that were adjacent to that intersection. And so the idea of taking those 4 lots and under non-storm events, really building a lot of recreation amenities and amenities for the community to get together and gather. And then, when you do have a storm event, then you have large areas again that can store water and then slowly release that water to the collection system. This overall project is about 90% complete in the design phase, and we expect construction to start in the foreseeable future here. The phase 3, which is the last one I just talked about, that's probably at about 60% complete. And one good thing I think all the communities can kind of learn from this is that HUD funding does allow this complete analysis of benefits, and we work with AutoCase to calculate the environmental, social, and financial benefits of the project and compare them to overall project costs, including maintenance and everything else. And the calculated DC ratio for this project was about 1.67. So it's really important to you that because HUD is going to have money that you can apply for from your community to do these types of projects, and just recognize that there are tremendous economic benefits for communities with this overall approach. So realize that as you can see, resilience is not just one thing. It's really a layered approach that allows for the mix of both gray infrastructure and blue and green infrastructure to result in this more holistic solution. And that's one approach that we really want to kind of stress here, that all of our communities are different. We all have different social and environmental issues, but every community can identify their opportunities and for the unique conditions that they're faced with. And in closing here, I would just say that effective solutions really requires all of us. And just a couple of things that I hope you've gotten from this presentation is that we all have multiple challenges, and we all will embrace probably different solutions. But the combination of all of those projects really addresses this overall improved resiliency of our communities. I would suggest that we all stay focused on addressing the most urgent challenges and do it simultaneously from a federal, state, and local perspective. I want you to always remember New Orleans and what happened to us here, because we didn't do it right. And this was in our response after we've already had $1 billion worth of damage and nearly 2,000 people killed. Okay, but don't think that it happened to us and it won't happen to you, because I think we all need to operate. You need to operate kind of from the mindset of it could happen to me, and it could happen to me at any time. Okay, and then I guess, and it's not just us. I think this is something that is really around the country and around the world. I think that's going to happen. And I think the goal for your community should be to prepare before the disaster. Don't wait until you've already suffered the loss of life and infrastructure damage that we did. And always remember that resilience is a layered approach. It takes all levels of government to achieve a holistic solution. Bottom line, it takes all of us at all levels of government and all types of infrastructure, maybe hard infrastructure, soft infrastructure, to address the problem. And the problem does not go away by ignoring it. The only way we get to comprehensive solutions is by all of us working together and learning from one another. So I appreciate you taking time and joining us today. We'll gladly answer questions, and or you can contact us later. And today I'm joined by Dan Grandal. Dan is in the New Orleans office. He was the design manager for the PCCP project. That's the pumps project in New Orleans. And he is currently the project manager for the Blue Green Corridors project. And we also have Scott Peaton, who is the project manager for the Mid-Breton Sediment Diversion project. So with that, I think we're about ready to open it up to questions.
All right, great. Thank you, Steve, very much. Very good presentation. Just a reminder, you just can feel free to put your questions in the questions box from on the GoToWebinar panel there. We do have a number that I will get to, but please continue to ask more. First up, Steve or Dan or Scott or all of you, can you explain, the question basically is wanting you to explain kind of how the funding worked between federal, state, and local to bring this holistic solution to the community of New Orleans.
Yeah, and I'll start out here, Dan, and I invite Scott and both of you guys to join me. But after Katrina, we were in such a crisis mode that the federal government stepped in and made an estimate of what the cost would be, provided that money, and they actually provided the state match to that project as well. We're paying our match back now, so our match was about $1.3 billion. So, that was one of those things that was an emergency response, and that's how we got to the perimeter protection around the city of New Orleans. The Mid-Breton project, as part of the master plan, that's actually being funded by some of the BP fines and penalties from the BP oil spill, and then Dan, I think the Blue Green project is actually being funded through HUD, if that's correctly. So it's not just one funding source that covers it all. It's and I guess in our situation, to be perfectly honest, we had Hurricane Katrina, and that was a disaster. but it also brought the response also brought federal dollars to the solution we have today. BP oil spill was horrible, but it allowed us money to build these types of projects that we have today. So we had a couple of big disasters here that allowed or generated funding sources for some of these projects. Dan or Scott, I invite you guys to add on.
Yeah, so for the blue-green corridors, it was HUD funding. It was a National Disaster Resilience Competition, and the city put a plan together and applied. The application was for I think it was for like 280 million. They got half of that. They got 140 million. The project that you saw is about 45 million of that overall program, there is a lot of federal funding similar, and there's a lot of HUD funding out there right now. And I think for communities, it's just important to have your plan in place and have your projects ready to go in order to get first in line on some of that funding, those funding opportunities that are coming out.
Okay, good. Thank you.
Next.
There's a follow-up on that one, specific to the local government response, and just looking for advice on what type of grant funding people should focus on to help get their projects designed and built. You mentioned HUD for Blue Green, but was anything else used, or do you have experience with any other funding programs that people should pay attention to?
So there's the BRIC funding, that resilience funding that's also under HUD, but then also under FEMA. There's hazard mitigation grant funding that's every year, there's available funds there, and that one is a little bit more restrictive than the HUD funding on what type of project it can be. Those are typically focused on the flooding mitigation, so it's less a little bit more restrictive, but there's new programs coming out. I mean, we have a whole group that focuses on the funding and kind of following these new regulations that are coming out, these new programs that are coming out to try to get, us well informed on when these things come out.
Yeah, and I might also add for everyone that this new infrastructure bill that's moving through Congress now, there's an enormous amount of money for resiliency projects, whether it be coastal. There's an enormous amount of money for water, wastewater improvements. So I would just, say work with your local congressional delegation if this does get passed, because there will be there's a lot of money that's going to be available there to help with these types of issues.
Yeah, and I think to add to that on the state level also, we've worked a lot with WIFIA grants and state revolving fund loans as well that are also a possibility for funding, and they're available every year as well in your specific state.
Yeah, but I think, Dan, you also will see with the infrastructure bill, I think some of those, there will be significant funding going into some of those revolving fund type programs to support this type of work too. So you might see an uptick in that.
All right, good. Sounds like a lot of opportunities for funding out there. Again, about the blue-green corridors, Dan, how is the city going to handle the maintenance once those things are built? Is the question.
Sure. So what they have done on this specific funding, and the HUD allows for this, is that they put 3 years of maintenance into the construction project, and that typically is the amount of time, or it's probably less than that some of these new landscaping and trees would need to be established. And so besides us making the plan with local landscaping that's going to survive, to try to make it low maintenance and do an installation that's as little maintenance as possible. They are using the grant funding for the maintenance in the first 3 years. And we have been working, we prepared a maintenance plan for the project. It is a pretty big project that covers a big area. So we've been working with also the maintenance agencies that typically would take care of the sewage and water board, that would take care of the drainage system, and then the Parks and Parkway and Parks Department that would take care of the facilities, parks and greenways that we're creating to make sure. One of the things that they're doing with green infrastructure, since that is a new kind of that typically for maintenance, they mow grass, right? That's the type of equipment they have, the type of expertise they have. So they do have a training program in place to kind of deal more with the green infrastructure and how you maintain it, how you upkeep it, and what type of staff and people you would need.
Yeah, that's a good point. I hadn't actually thought of that. Following on that, there's a question about, in your opinion, any of you, what's the most effective strategies for engaging the private sector, basically industrial, commercial, institutional sector, in the uptake of green infrastructure solutions on private land instead of public?
So giving them money always works. But you know, the part of the overall program that they did with HUD, they did have a piece of it that was dedicated to creating pervious space on private property, and that is one avenue that you can do is to, you know, have some grant money to install green infrastructure on private property. Another thing that the city did was change their regulations, right, for new developments to hold a certain storm event on site, and to I believe they have a stormwater ordinance requiring some green infrastructure, and they also have in lieu of payment, so that in case you can't, or the developer doesn't want to have that stormwater storage or that green infrastructure on their property, they can pay the city a certain amount of money, and then the city would use that to then create more green infrastructure or storage in the system.
I'll just add, you know, helping those landowners realize the full extent of their the value of their property is important, beyond just a flood risk reduction benefit or a stormwater benefit. Having them understand the natural capital value of their land, you know, all those secondary and tertiary benefits that they may not be thinking of or taking advantage of. It's important for us to educate them on those secondary, tertiary, other benefits that are equally, you know, just as important as the flood risk reduction benefit associated with green infrastructure.
Yeah, and I would also say, you know, part of this change in mindset in New Orleans, again, I think there's a lot of pressure on a private sector because of what's happened in the public sector. That is, you know, when the city comes out and is building all this new green infrastructure, people are really liking this. They like the look of it. They want to be more. They want more parks. They want more stuff. I think that puts a little pressure on the private sector to sort of say, well, in my development, those same people are, you know, they have the same priorities. So if and I know this because of some of these in some of these developments downtown, the amenities that are being built with these new developments are greatly different than they were before Katrina. And whether it be the whole dog park thing or whatever, you know, people, there's been a shift in mindset really over the past 10 or 15 years. So, you know, I think that's part of it too, is that there's going to be this social mindset, and realize that what we had in New Orleans, you know, again, I go back to, you know, we were responding to a disaster, and, you know, the feds did one thing, and the state had been looking at how do you rebuild the coast for a long time and got money, and they did this. I think in most communities, the things that they could do on their own would be this blue-green infrastructure type work, because it's not to the level of the expense of a flood protection system, and with all these other amenities that are that are part of those projects, all these, green amenities and environmental amenities that people really like, people can enjoy those amenities and not just put all of your eggs in the basket of waiting for the big storm. Because if you don't get the big storm for 10 years and you have time to build your hard structures, you have this other stuff that you can enjoy over that period of time too. So, I would just say that cities and small governments, you shouldn't wait for just the big projects to make the environment better. That there's all these other things that you can be doing very proactively that citizens really embrace.
Yeah, and one other point there is there is a public education piece as part of blue-green corridors. It's a new kind of approach, as Steve mentioned, and part of our public engagement has been to explain green infrastructure, how it works, how the drainage system overall works, how those two tie together. So there's a little bit in the public engagement, but then there's also some permanent kiosk of explanation on green and blue infrastructure throughout the neighborhoods to really get those private property owners to understand the benefits completely.
All right, good. Well, we've got a couple minutes left here, so I'll go ahead and let everybody, if they're interested, I'm going to give you a chance to unmute yourself if you'd like to ask a question live or comment or follow up. You're welcome to do that now here in the last couple minutes that we have. And while people decide if they want to or not, has PCCP been activated due to a storm event? Dan, that was a question that came in.
Yeah, so we haven't had a Katrina per se, a Category 5 storm, but we have had several hurricanes where the water in the lake has gotten to the point where they had to close the gates up. And a couple of those storms, they did activate the pumps because they also had some rain on the interior. So yeah, it's been, besides the maintenance testing that happens every month, it has actually been used in a storm event.
Thankfully not tested too hard, huh?
Yeah.
Yeah. All right, well, I think that's it for the questions. Just want to say thank you to the presenters very much, obviously, for taking the time. Thank you to all of you that have joined and listened and asked your great questions. Again, feel free to watch the recording or pass the recording along. It'll be up on the website in a couple days. Check the chat box and you'll see a link out to our webinar page. And we hope to see you on a future webinar. Starting again next month, we'll have one. So thanks again to everybody and hope you have a good day.
It was a pleasure, folks. Thanks.
Thank you. Bye-bye.